Hey kids, welcome back to some more science. Science is cool. We are moving on to some chemistry now. I mean, chemistry is what most people think of when they think of a scientist, but chemistry is only one kind of science. We've learned about anatomy, which is not chemistry. We learned about space science, not chemistry. We learned about bats, nocturnal animals, and ocean critters, not chemistry. But finally, we're going to learn about some chemistry, which is why I'm wearing my chemical robe here and some safety glasses. Because a chemist's job is often to put things together and see what happens. That's chemistry. Our first chemistry unit, our first kitchen chemistry unit, is going to be leavening agents. Things that make other things rise up. So think of a pancake and now think of bread, a loaf of bread. A loaf of bread is really fat, but a pancake is very flat. We are going to talk about why that happens and what we need to do to make our food look and taste the way we want it to. So this week you are going to learn about baking soda, baking powder, and yeast, 3 leavening agents. We're going to do some experiments using these 3 ingredients. What's the difference? Why would you use one or the other? And at the very end, you are going to bake your very own baking powder buttermilk biscuits. So let's get started, because science is cool. We're going to start off this unit with a little video. This video explains the history behind yeast, baking soda, and baking powder. Let's watch.
Hey, it's Danny here, reporting to you from the woods, and we just got done with an early morning bike ride. And we are hungry. But I have a question for you, though. What do you think is the most important thing in making these flapjacks?
Well, I'll tell you one thing. It's not the steel pan. He could have cooked these babies on a hot, flat rock.
I'll tell you what it is. It's the baking powder.
That's right. And to understand why baking powder and the chemist who invented it are so cool, we're going to delve into a little history of bread.
Throughout history, bread fed armies, built nations, and fueled exploration around the world.
No! No!
But there were a few hiccups along the way.
Around 1500 BC, Egyptian bakers discovered that yeast growing in old dough, or sourdough, made the dough rise.
That was huge. It made bread soft, it made it taste good, but most importantly, it made bread last. So now people could survive cycles of feast or famine because they had bread to carry them through.
Bakers used fermented sourdough or yeast for leavening for 3,000 years. But yeast, with all its benefits, isn't the easiest thing to work with. Yeast is a living organism, a fungus that can be finicky. For yeast to grow and convert the sugars in dough to carbon dioxide bubbles that make the bread rise, the conditions have to be just right. The yeast has to be cultured, kept warm, then wait for it to produce enough gas bubbles to make the bread rise.
Who had time for that?
Then, chemistry revolutionized baking with something called quick breads. This was the first time in history that people didn't have to carry around a living organism to make their bread.
That's so old school.
In the 1830s, bakers began adding sodium bicarbonate and sour milk to their dough. Lactic acid in the sour milk reacted with the sodium bicarbonate to produce carbon dioxide bubbles in the dough that made it rise. But bakers never knew how sour the milk was, so they couldn't predict or control the reaction.
Chemists came up with a temporary solution in the 1840s. They combined cream of tartar, a byproduct of wine fermentation, with sodium bicarbonate. Combining 2 chemicals solved the problem of unpredictable results, but cream of tartar was expensive and sometimes hard to find.
Enter Harvard chemist Eben Horsford, inventor of baking powder.
I replaced cream of tartar with calcium acid phosphate. I call it monocalcium phosphate. My early source for calcium was cattle bones, which we treated with sulfuric acid. It wasn't easy to make. Plus, bakers still had to mix 2 reactants. So, I solved the problem by drying the ingredients and added cornstarch as the vital third ingredient to keep the powder dry and keep it from reacting with the moisture within the can. Voila! Baking powder. In the late 1880s, people mined for calcium phosphate, which eliminated the need for decades, baking powder contained the same three ingredients: calcium acid phosphate, sodium bicarbonate, and cornstarch.
Evan Horsford was a chemical pioneer who changed the face of baking. His baking powder made baking easier, quicker, and more reliable.
Chemistry was the key to making quick breads.
And thanks to an American chemist, we solved the age-old problem of using finicky yeast. His solution using chemistry finally made baking cost-effective, dependable, and it changed the way bakers baked in kitchens and bakeries across the nation. Who knew there was so much chemistry behind baking powder?
Which is another great reason to never stop exploring your world.
Okay, so in that video we saw how different kinds of leavening agents help to make bread fluffy. But let's back it up a second and do an experiment, a demonstration of what this looks like. I have here some baking soda, a bottle, and an acid vinegar. Baking soda, when I add it to the acid, something's going to happen. Right now, they're just sitting by themselves. Nothing's happening. There's no reaction. That's not chemistry. Chemistry is when you combine them and something happens, a reaction. Safety first. When I'm cooking, I have my baking soda in my recipe. Add a little bit in there. Okay. Then I add flour and other ingredients. Now the flour binds together like a net, like my balloon. It traps the bubbles that are going to get made when I put these two together. When I add the vinegar, the acid, to the baking soda, it reacts and it makes bubbles. My dough, my flour, is going to trap those bubbles, just like this. Okay. I have put a balloon on top to trap the bubbles coming out of this reaction. And you can see, balloon's getting kind of big. It's trapping the bubbles and it's rising. This is how your dough would work too. It would cause your dough, your cookies, your pancakes, whatever, to rise. That's a reaction. So now that we have an understanding of what is a reaction, let's do some experiments on reactions. First, let's do an experiment with yeast. Yeast is a leavening agent. It causes a reaction when mixed with water. Now I have added a little bit of sugar in there because sometimes yeast needs that. Our video stated that yeast is wonderful for making breads, tastes fluffy and delicious, but the problem is it takes a long time for that reaction. You have to wait for that to rise a long time. So let's find out how long. I have here a jar of yeast, which right now isn't doing anything. It's dormant. It's sleeping, I like to say. Just sitting in there. Smells like bread. You can see it just looks like sand though. So if I take a little bit of this and I add it to my water, mix it up a little bit. That doesn't look very good. Ugh, doesn't smell very good either. That's what it looks like right now. It's not rising, it's not making bubbles, nothing's going on right now, at least that I can see, except that it's just all swirling in a circle. Kind of looks like dirty swamp water. We're gonna set that aside. Keep an eye on that. Let's move on to our next step. For this first experiment, we are gonna just take a look at the difference between baking soda and baking powder. As we learned in the movie, they're very similar, but they're not quite the same. Let's start with the baking soda on the orange plate. I'm going to put a blob of it right there. And I'm going to put a blob of the baking powder on the pink plate. Let's take a look at them. Well, they look very similar. They're both white. This one looks more powdery than this one looks kind of chunky. Let's see how they react. I have here 2 cups. I'm going to put some water in this one. And I'm going to put some vinegar in this one. If I ever forget which one's which, I can just smell them. Okay, Now, let's put this over here, and let's move that there. Okay, let's add water to both of these ingredients. Actually, what I need to do, I need to put 2 on there, because one's going to have water, and one is going to have an acid, in our case vinegar. And what happens? Okay, there we go. Now, let's start with the water. If I add water to my baking powder, what happens? Can you see? It is starting to bubble. It's foaming. When I drip water onto the baking powder, it foams. The water and the baking powder react. The water causes the baking powder to react. Let's see if the same is true for the baking soda. Got a little eyedrop of water. That's not doing anything. All it's doing is getting it wet. No bubbles. The water does not cause a reaction when it mixes with the baking soda. Only with the baking powder. Let's see if we add an acid. Our stinky, stinky vinegar. Now I'm going to add stinky vinegar to the baking powder and see what happens. Can you hear it? It's reacting. It's bubbling. How about the baking soda? Wow. That does bubble. So what did we learn from this? Well, we learned that the baking powder will react with either the water or the vinegar, the acid, whereas the baking soda only reacted with the acid. That begs the question, what else has acid in it? How do we find out? I know. If we want to find out if a food is acidic, we could just drip it on our baking soda and find out if it causes a reaction. Should we do that experiment too? Let's do it, because chemistry's cool. Okay, let's find out what else has acid in it. What will react with our baking soda? Here's our baking soda. Let's try some soy sauce. Do you think that's going to make bubbles? I don't know. Let's find out. Nope. Just made it all wet. Soy sauce is not acidic. It will not react with the baking soda, which is probably good because soy sauce cookies would be really gross. How about some milk? Is milk acidic? I don't know. Let's find out. Well, that made a mess. Nope, just making it all wet. Nope, milk is not acidic. Nope. How about lemon juice? Is lemon juice acidic? I don't know. Let's find out. Ooh. Oh, look, something's happening. It's bubbling. Ooh, can you see it? It bubbled. It's that one. Lemon juice is acidic. Let's drop some more of that on there. Yep. Wow. Yes, we have a winner. Lemon juice is acidic. And my plate is getting messy. Before moving on, let's take a look at our yeast. Wow, can you see what's going on in here? Those bubbles are getting really, really thick. Ooh, and it's smelling a lot like beer, which has yeast in it also, and maybe like bread too. So you can see, look at those bubbles. Those are better than any bubbles from the other two ingredients, but it's taken a while to get here. Cool. That's a pretty cool reaction. So baking soda reacts with an acid. That's great. That means we get fluffy food. But there's a problem with this. See if we can figure out what it is. Here's my baking soda. Here's my acid. There's my bubbles. I've just made my cake, I've mixed it up, and I'm getting ready to put it in the oven. But before my batter can cook up all the way, I've run out of bubbles. the reaction is complete. There's no more reaction. It's not going to make a very fluffy cake that way. And that is why we have baking powder. If you can read the can, it says double acting baking powder. It doesn't just mean words, it means it acts twice. The first reaction is when it mixes with the wet ingredients in your batter. It starts to make those bubbles. But before those bubbles can die out, you put your cake in the oven and the heat causes a second reaction. You can see this in action when you make pancakes. When you put the batter onto the skillet or the pan, you have to wait until bubbles start to form before you flip it open, because that is your double acting baking powder reacting. For this next experiment, I've got two different batters here. Each of them has flour, salt, and sugar. In these cups, I also have milk, butter, and eggs. The difference is this one has baking powder in it. This one has baking soda in it. Remember, baking powder is double acting. When you heat it up, it acts again. So we're going to test that and see what that means. I did add a little bit of lemon juice to my milk over here, so that there's a little bit of an acid. Otherwise, nothing would happen to this. But let's get going here. So first, I'm going to add the liquid to both of these and stir it in. Let's take a look. They don't look that different. Both kind of runny. They're both kind of the same color. Let's see how they cook up. This one is the baking powder one. This one is the baking soda one. Okay, they're both cooking. They're both bubbling. Looking pretty good. Okay, let's take them off. They look the same. Here's another pancake I put on with that baking powder. You can really see those bubbles forming. That's the double acting, telling me it's time to cook it some more. Ooh, that's beautiful. The double acting baking powder bubbled up some more when it hit the heat of the skillet. I've added some more batter of the baking soda one. Now that the pan is hotter, we really get to see if that double acting is going to kick in or not. It did kick in with our baking powder one. We saw it bubbling. Let's see what happens here. There is no double acting, only one reaction. And not only that, my batter's been sitting a while, so probably all those bubbles got used up. I'm not expecting great things from this one. All right, I kept waiting for this to bubble to let me know when to turn it over, and it's not really doing much, but I can see that it's already dark on the bottom, so I'm gonna flip it. Wow. Yep, not as many bubbles, definitely not as many bubbles. Okay, for a true comparison, I have another batter. Now this one doesn't have any leavening agents, no baking powder and no baking soda. It's still watery, same ingredients. I just accidentally left out something. This does not look good at all. Let's see how this goes. Well, I finally flipped it over because it had been in there so long, and it's still not very brown, and it doesn't feel, it feels like a tortilla. Does not feel like a nice fluffy pancake. Wow, you never think the stove is hot. It's not even getting brown. Look at this. I think this experiment is over. Let's take it off and compare everything. Okay, got my results. I've got my baking soda with the acid, so it should leaven, should rise. I've got my baking powder, which rises by itself with the milk. And then I have this kind of sad looking thing in the middle with no leavening agents. Take a look. All right, let's start with the baking powder one. I'm gonna break it open. Wow, nice and fluffy. That looks good. Let's break this one open. Pretty fluffy too. Yeah, I'd say, you know, those two leavening agents, pretty similar. Let's see how they taste. You know, this one's kind of bitter. Ugh. Between the baking soda and the lemon juice, that's not a good taste. Looks good, but ugh. Oh, wow. Oh, this one's good. This tastes like a pancake. Okay, so that's something important. They look the same. They both rose about the same with their leavening agents, but the taste of that one just isn't good between the bitterness of the baking soda, which you have to use, and the lemon juice, it was too much. Now I know that a lot of baking soda pancakes use buttermilk instead of lemon juice and milk. That's why. Buttermilk will cut down that taste of the baking soda, which you really need, because blech. Should we try this one? This is really heavy. Ugh. It doesn't even look cooked. I don't even want to eat this. It's all for science. You know, it's better than that one, but it's very dense. It's kind of like eating Play-Doh. Not that I've eaten Play-Doh, but I imagine it would be like eating Play-Doh. I think that we can all agree that the best pancakes are going to be using our double-acting baking powder. And then you get the fluffiness without the bitter taste. You I love.
Cooking project time! Here is the recipe for the biscuits. Take a screenshot and print it out. Here are the ingredients you're going to need to make your biscuits. White flour, white sugar, baking powder, baking soda, salt, buttermilk or milk and lemon juice, and 6 tablespoons of cold butter, not melted.
So the very first thing on my recipe to-do list is to pour out and measure a cup of buttermilk. Well, this is buttermilk. I don't always have buttermilk, and chances are you might not have it either. It's not something usually in your fridge, but I can make buttermilk. Buttermilk is just milk that is more acidic. So I can pour in a cup of milk and add 1 teaspoon of lemon juice, my acid, and that will make buttermilk. So if you don't have any buttermilk, you can do that too. Okay, moving on, while I'm waiting for my milk to curdle, I'm going to start with my dry ingredients. I'm going to need 2 cups of flour, 1, using my knife to scrape it clean so I get just 2 cups, and 2. Next, I'm going to add 2 teaspoons of white sugar. Just a little bit of sweetness. It's not a cookie, it's a biscuit. 1, 2. Next, I'm going to add a tablespoon of my baking powder. It's kind of a lot of baking powder, but I want some fluffy biscuits. That's what my recipe says. And finally, I'm going to add a 1/4 teaspoon, just a little bit, of salt and a little bit of baking soda. And they all go. I'm going to whisk these all together with my whisk because they're dry ingredients and I don't want them flying all over the place. Just enough to mix them up. Now I'm going to cut in my butter. With biscuits, the butter needs to be cold and you need to cut it in. Right now it's kind of hard. So the best way to do this is to chop it into smaller pieces. It is hard. And then we're going to use a pastry cutter or 2 knives, or if you're really fancy, you can use a Cuisinart or some kind of food processor to chop the butter in. You don't want to put an electric mixer in there. That's going to chop up the butter. Won't work. To make fluffy biscuits, it has to be chunky. Okay, so I need 6 tablespoons of that. Okay, got my butter chunks in there. I'm ready to get going. Now, we've used a pastry cutter in past videos, but if you don't remember, this is a pastry cutter. It's got some edges on it that aren't sharp. I won't cut myself, but I use them to cut the butter. Chop, chop, chop into smaller pieces. And the butter's a little sticky, so it gets stuck in the flour. It also gets stuck on my pastry cutter. That's what the knives are for. Scrape it out. If you don't have a pastry cutter, you can use the 2 knives instead. I'll show you that in just a second. Use them in a crisscross pattern, like this. That does the same thing. Make sure you're chopping across the butter. It does an okay job, but the pastry cutter's better, so I'm gonna go back to that. When it's all done, it looks like that. butter's all kind of chopped in and covered by flour. It looks like, I don't know, a little chunky flour. Now we're ready to add our wet ingredients. Pour my wet into my dry. And then I'm gonna just stir it up, until it's just mixed. It's gonna be sticky. It's not a cookie dough that you can scoop out. Just until it holds together. Okay, make sure all the flour is mixed in. That looks pretty good. Make sure you scrape the flour off the bottom. Okay, now we're gonna drop it onto our baking sheet. Plop. I did line my baking sheet with parchment paper because it just makes cleanup easier. Keeps everything from burning. Plop. So here are my biscuits. I got 12 out of that recipe. And even as I'm scooping them, I can see that they're starting to look kind of fluffy. That's the acid and the baking powder already reacting. Now I'm gonna put this in the oven, which is gonna cause another reaction. When heat hits that baking powder acid combination, it's gonna cause it to rise even more. And I should get some fluffy baking powder biscuits. In they go, 400 degrees. Let's give it a whirl. Okay, they're done. Wow, they smell really buttery. And you can see they didn't grow a whole lot more like bread would. When we make bread, it really rises because that is a different leavening agent. Both cookies and biscuits may be tall, but the difference is on the inside. When I broke this open, look how fluffy it is in there. There's a lot of air in there. That's what the baking powder does versus baking soda. See how it tastes. You know, this would be really good with some kind of jam on it, or jelly, or maybe even fresh strawberries and whipped cream. Very delicious though. Baking powder biscuits, a good use of leavening agents. Here we go. I just wanted to show you one last time what this is doing. It's still going. Yep, still going. This yeast takes about an hour to really double its volume. So that's why breads take so long. As soon as you mix everything together, you have to let them rise for about an hour so that it can make all these bubbles. Woo, sure does smell. Well, that's all I have this week on kitchen chemistry, leavening agents. Kitchen chemistry is cool. Chemistry is cool. And science is cool.